and you line it up from Alexandria to Cairo, right? And when you do that, right, you almost draw a line between the two, okay? As you draw a line between the two, right, you bring it down here to the scale, and you can figure out how many kilometers or how many miles it is in between. So you have to have a scrap piece of paper for that. Okay?
So, like, to measure kilometers, you have to, like, use a piece of paper?
Right. So even if this is if I gave this to you on a test, I'm joining this from my iPad, guys, so I can try and show it to you. Okay? I am the first one here. No, I'm not. I lied. Okay. So, what you're going to do is you take a scrap piece of paper, right? When you take a scrap piece of paper, you line it up between Alexandria and Cairo. All right, give me 1 second, and I will show you what I mean. My paper. All right, I'm going to join this, hopefully. Okay, so you see my screen there? Right? I take my piece of paper and I put it up against the screen here, and I take a mark where Cairo is and a mark where Alexandria is, and I bring it down to the scale. Can you guys still see that?
No.
I can't see.
No.
Oh,
No,
okay.
we can't see it.
Okay, hold on. Hold on. Sorry. I don't know why it's not working. I will try again a different way. Okay. Okay. So, how do I do this? Can you guys pin me? I'm over here on the right-hand side. I'm like flipping my screen so you can see me.
Wait, pin you or what?
Pin me.
She has two of her.
I'm in here twice. Pin me here. Okay.
Should we pin the one that's muted?
Yeah.
Oh, I had it. All right.
You see how I'm like moving the screen a little bit? Okay.
Yeah, I got it.
So, what you do is you take your scrap piece of paper and you put it up against your screen, and you put a mark where Cairo is and a mark where Alexandria is. Okay? Then you bring it down to the scale here. Right? And then it is very easy to figure out that this is between 100 and 200 kilometers. It's about halfway between 100 and 200 kilometers, so it should be about 150 kilometers apart. Okay? Do you guys see that?
Uh-huh.
Yes.
Okay. There's actually a way for you guys to lock your screens. Okay. All right, I'm going to go away now. All right. On your iPads, if you all go with me to settings. Okay, it is settings, and then I believe it's general. Where are we? Then go to accessibility. Right? Then go down to guided access. And turn guided access on.
I don't have accessibility in my school iPad.
Yours might be.
Neither do I.
At the bottom of general.
It's still not there.
It's not there.
Look for guided access. It's literally called guided access. And turn that on.
In general, right?
It might be, yeah, it should be in general. All the way down at the bottom.
It's not there.
It is on mine.
Did you get your iPad from the school or no?
Yes.
Huh.
It's not in general. If you look down like 3 spaces below general, it says accessibility, and click that.
I thought it was in general. My bad.
Mine is an older iPad. So if you guys can help me out with this, they haven't given me an updated one yet. They're supposed to, but then we closed down. So this is totally fine. So just, it's 3 down from, you said from general, you click on accessibility.
Yeah.
And then scroll down to where it says guided access. Make sure that is on. Okay, and I'll show you why.
Do I have to change any settings when I turn it on?
Turn it on.
All right.
Okay. Now, what that does by having that on is if I want to, I can actually go into, let's say, Notability. So if I give you a worksheet and I ask you to find the scale of all this stuff, you know, you can actually screen. It's basically like you're freezing part of your screen. Okay. So let's say here's my selfie. Right. You guys all see that? See like my selfie from the lab?
Yeah.
Yeah.
Okay. So if I triple click, it gets really small, right? You circle the area that you want to basically disable so that if you touch it, it doesn't go anywhere, right? I can move this around. I can make it bigger. I can make it smaller, so on and so forth. So let's say I want to focus just in on that one picture, right? Then in the top right-hand corner, I click Start, right? You put your passcode in. Okay, now that's highlighted. So look, here I can move. If I put my fingers on the right-hand side, I can move it. But if I put my fingers on that circle and move up and down, I cannot. Okay, so that's going to come in handy when we do latitude, longitude, when we do topographic maps, because you're going to have to be touching your iPad, and you don't want the picture to move.
What's that 7th tool you have on Notability in the middle of your screen?
I have no idea. This thing?
The one that looks like, yeah, that one.
I have no idea.
Miss G.
And hold on, to get out of it, you triple click again, put your passcode in, and then you can click end, and it disappears. What's up?
So, you was talking too fast, so I didn't get to get your definition on latitude and longitude.
We haven't even gotten that far yet.
Okay.
Yeah, don't worry. We haven't gotten there yet. Okay, so I'm going to stop sharing that one, and we're going to go back over here and resume. Okay, so that's just kind of a side note, guys, and a little trick, right? When you are doing these kinds of questions, and especially because you're going to be using your iPads a ton more than you would normally use them, you need to know that little trick with accessibility, so that way, I'm sorry, with guided access, so that the screen won't move. Okay, because otherwise, if you go to touch the screen, maybe it'll zoom in by accident. Maybe, you know, you're going to put your piece of paper over it, and then something else is going to happen. Okay, so we need to know a coordinate system in order to basically map out the Earth. That coordinate system, right, forms, right? Basically, it's latitude and longitude. It forms a grid on the Earth. It's invisible. It's not actually there. Okay, so latitude and longitude is just a coordinate system. Okay, so let's talk about latitude. All right, here we have 2 pictures. All right, basically the way that you actually figure out the angles is you look on this left-hand picture. You have a straight line that comes across from the center of the Earth to the equator. Then wherever you are on Earth, you're going to create the second line. So in this case, we're all the way up here, right? And we bring it back down. So if we're standing right here at the top of this line, right, we're going to draw a straight line down to the center of the Earth. That angle that is formed is going to be our degrees latitude. Okay, that's where these numbers come from. It's just the angle that is created between the equator and wherever you are. Okay, so it's an angle. That is created from the center of the Earth to wherever you're standing, either north or south of the equator. So the equator is going to be your guided line. Okay, they are horizontal lines that run from east to west, but you're going to say 30 degrees north or 30 degrees south is going to be your latitude lines. Even though they're running from left to right or east to west, it's almost better if you say it as left to right, because then you don't get as confused. With latitude and longitude, you must put compass directions, north, south, east, or west. Okay, because since we're talking about half the Earth being north and half the Earth being south, right, you have to be specific. Otherwise, how do I know? If you, God forbid, got lost to sea and you tell me I'm at 30 degrees, are you up here or are you down here? That's a lot of area for me to come find you, right? So you have to be specific. With latitude and longitude, you have to say north, south, east, or west. And the more specific you can be, the more likely that we can rescue you.
Can you say the measure again?
The what?
You said 30 degrees for the measurement?
Just in general, if you got lost at 30 degrees, right, are you talking about 30 degrees north or 30 degrees south? That's a lot of area for me to cover to try and rescue you. All right. In general, latitude and longitude are measured in degrees, minutes, and seconds. In this class, you're not really going to be using seconds, okay? But if you were going outside of this class, the more specific you are, the better, all right? Latitude is only going to run from 0 degrees, which is where the equator is, to 90 degrees. In general, it runs from 0 to 90, okay? No more, no less. There's no negative latitudes, per se, I should say. Okay. All right. So it goes from 0 to 90, either north, or 0 to 90 south. So latitude lines are parallel to each other. Okay. And that's why they're also called parallels. So the fact, this is a trick that my math teacher told me when I was in high school. You see how the word parallel has 2 L's next to each other?
Yeah.
Right? That's what a parallel looks like, is you have one and then you have the second right next to each other. They run along the same path. So the fact that it has that almost that like double yellow line in it, that's what parallel means. They run right next to each other. Okay. Now, we talked about yesterday how the Earth is actually round and not flat. So as you get closer and closer and closer to the North Pole or the South Pole, the actual lines of latitude are going to, in length, are going to get shorter and shorter and shorter. The longest line of latitude happens at the equator. I'm not going to get into that right now. We'll come back to that one in a minute. Okay, so here we go. We're getting there. So does anybody have any questions on latitude before I move on to Polaris? Okay, so to sum it up, latitude goes from 0 to 90, either north or south of the equator. Okay, they are the horizontal lines that wrap all the way around the Earth. Okay. And as you get closer to the poles, those lines get smaller and smaller. Okay, now, Polaris. You may or may not know what Polaris is. Polaris is the North Star. Okay? It's the one that you use to find your way home if you are lost in a woods somewhere, right? There is a version of that in the South, but we don't need to know it for this class. Just letting you know, yes, they do have a South Star, quote unquote. Okay? When you are looking at Polaris, Polaris is basically at what's known as a zenith. Zenith means above, directly above your head. Okay? So if you're standing at 90 degrees north, Polaris will be at your zenith. So zenith, or Zenith, Zenith, means directly overhead. Okay? If Polaris is at your zenith, you're standing at the North Pole. Okay, this is what I was just telling you, right? If this is Polaris and you're standing at the North Pole, the angle of Polaris is going to be a right angle, right? Because to find the angle of Polaris, you take one arm and you put it straight ahead, like at your line of sight. Make like a 90-degree angle with your body. Then your other hand is going to point to where Polaris is. The angle that is created between the two is known as the angle of Polaris, or the altitude of Polaris. Right. Okay, before I get to this, okay, so Polaris will be at your zenith when you're at the North Pole, so its angle of Polaris would be 90 degrees. The latitude, though, for North Pole is 90 degrees north. So they're both at the same angle? That's interesting. Okay, so when you were looking at this, okay, anytime you're asked to find the angle of Polaris or the altitude of Polaris, you should write down latitude of the observer. Okay, so anytime you're asked to find the angle or the altitude of Polaris, you should write down latitude of the observer. Because wherever you are in the northern hemisphere, okay, wherever Polaris is, that angle that is created will be your latitude. Now, the only difference is, and this is very, 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 very important, is that an angle, you do not need a compass direction, but a latitude line, you do. Okay? So for an angle, you do not need a compass direction, north, south, east, or west, but for a latitude or longitude line, you must give me a direction. Okay, if you were to give me, let's say, 90 degrees north as the angle of Polaris when you're at the North Pole, you're incorrect. It does not work that way. You cannot have a compass direction for the altitude or angle of Polaris. You guys with me so far?
Yeah.
Okay. All right, so if you're standing at the equator, Polaris will be directly in front of you at the horizon, right? So the horizon is when you put your arm straight out in front of you. It's your kind of your line of sight, right? If you're standing at the equator, since the angle of Polaris is equal to the altitude of the observer, or the latitude of the observer, right? And the equator is sitting at 0 degrees, then the angle of Polaris is also 0 degrees. Okay? This last line down here is important. Okay? This last line here.
So do we have to copy all of that last line? Okay, no.
Would you be able to post this on Classroom later today?
The video I will, yes.
Okay.
Okay? We sit at approximately 41 degrees, north. Okay? If you guys look on the reference table, page 3, I believe it is. Okay, it's a map of New York. Okay, when you were looking at it, we're pretty much between 38 degrees north to about 44 degrees north. The entire state sits between there. So depending on where you are in New York, okay, will tell us the angle or altitude of Polaris. Okay, so if you're ever asked a question about Polaris, about some random city in New York, you should know to look at the reference table on page 3. Okay. Okay, so we said yes, 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 we did that. We did that. Right, altitude Polaris equals latitude. Okay, so this is what I'm talking about in picture form. Here we are, standing right in the middle here. This overhead of us is called our zenith, directly overhead. So the angle, right, here's our horizon. It's directly in front of us, right? Go all the way down to the center of the earth here, and this angle that is created between us, between the horizon, I should say, and Polaris over here, this one over here, is going to give us the angle of Polaris. Right? No, that's not going to work. Right? Now, there is a way to find Polaris, because when you go outside at night, there are millions of billions of stars outside. How are you going to find the one that is Polaris? Well, we use what's known as pointer stars. All right, so we have the Big Dipper here. Right? The Big Dipper kind of looks like a ladle, like an old school ladle that has a handle here and a cup here. Right? These two here are known as the pointer stars. Okay? These pointer stars, if you were to draw an invisible line from the pointer stars, it would hit the next star, and that next star would be Polaris. Okay? So if I asked you to, and I gave you the Big Dipper here, you would draw a straight line from the pointer stars until you hit the next star. The next star would be Polaris. Okay. Right, so here's a picture of it. Draw a line from it to Polaris, right? Right. Now it's approximate because the stars have moved over the years, right? It just happens to be the last star in the handle of the Little Dipper as well. So if you can find the Big Dipper in the sky, you draw an invisible line, and the star that you hit is Polaris. That should be attached to another one that looks like this, just smaller. So it's Ursa Major to Ursa Minor. So this is what we were talking about, right? You guys couldn't see it, but I was doing it in the video. So here we have our right angle. Here's our zenith, right? Here's our horizon. That creates a right angle, right? However, where you are pointing, okay, is where Polaris is. So the angle that you're looking at is the one between the horizon and the, basically the line you drew towards Polaris, okay? This is not it. It's between the horizon and the line that you drew. Now make sure you understand that, because on the Regents and on your quizzes and tests, I could give you a picture that just shows you this, and then you need to figure out which angle I'm talking about. Right? All right, so let's talk about longitude. Right? Longitude is because it's long lines. They go from one pole to the other pole. So from the North Pole to the South Pole in both directions. Okay? Latitude, right? We started at the equator and either moved up or down, and the latitude lines did not touch each other. In longitude, they actually wrap all the way around the Earth longwise, from one pole to the other. Okay? So in this case, our directions are from east to west. Even though they run up and down, our directions are going to be east and west. And just like we had for latitude, where equator was our reference line, the prime meridian is our reference line for longitude. And don't you worry, when we are done with all of this, whether it's today or Monday, we will be doing practice problems on reading and figuring out the latitude and longitude of specific areas. Okay, like I said, it's vertical lines that run up and down, but they measure east to west, right? So you're never going to say, I'm 135 degrees north, right? Because we said that the lines of latitude go from 0 to 90, right? They do not go higher than 90 or less than 0. Longitude is going to go from 0 to 180. Okay, from 0 to 180. Okay, so the way that longitude works is that you have two, actually technically two reference places, right? You have your 0 degrees, which is the prime meridian, and then on the other side, on the exact same position on the other side of the earth, is going to be what's known as your international date line. So that's going to be 180 degrees away. And if you think about it, it makes sense because an entire circle is 360 degrees. We're talking about halfway, we're talking about 180. You guys okay?
I'm still writing.
Okay, no, I know. I just want to make sure you guys, I know it's a lot of information.
Yeah.
It will, I just have to intro it to you guys, and then we're going to do practice together. Then it'll make more sense. So a lot right now is just the note taking of it, and then once you actually physically do it, it'll make more sense. And you're going to need your reference tables. All right, you guys good?
Yeah.
Yeah.
Anybody not okay? Okay. So, like I said about longitude, right? It runs from the top of the poles and then all the way down. Think of it like an orange, right? It's not a straight line down. It's curved, right? The side of an orange actually will peel on those lines. This picture actually really looks like an orange where I could just pull this slice out, okay? Notice how it's definitely curved lines. It's not a straight line, okay? So longitude is because it's the long way, right? This is the same picture that you had for latitude, but now it's for longitude. So it's the same thing. It's the angle from the core basically to the equator. So wherever you are on the earth, it's going to be an angle from here to wherever you are on the earth, okay, which is pretty much on the equator, okay? So the prime meridian is going to be on the side that says 0 degrees. The international date line is going to be on the other side at 180 degrees. The international date line, guys, is basically where the government or just people in general have said or have gotten together and said, okay, if you cross over this line, it's Tuesday. If you cross it over this way, it's Monday. It's basically determining what day you're in. If you've ever flown before, very, very, very far away. You start off at Monday in New York, and then it's Tuesday by the time you get to China. Or I should say it should be Sunday when you get to China. It's the other way. Okay, it just depends on which way you're flying. Okay. So, now lines of longitudes are also known as meridians. So if you see lines of meridian, it means lines of longitude. These are not parallel lines. Okay, they are not straight lines next to each other. They are slightly curved, and they meet at the poles. Right, so they're also called meridians. Each one of the lines is of equal length. All right, so this line is exactly the same length as this line, which is exactly the same length as this line, so on and so forth. Okay, as you travel from north to south or south to north, if you think about this, this should make sense, right? If I travel from, in normal circumstances, from New York to Disney, right? Did I have to change my watch or the time?
No.
No. Why? Because I stayed on the same line of longitude. However, if I fly from here to California, does my cell phone change? Does the time on my cell phone change?
Yes.
Yeah.
Yeah.
Because of the fact that you're going from one line of longitude to another. Okay? Each one of those lines are called 60 minutes. Okay? So every time that you cross a line of longitude, whether it's to the right or the left, you're either increasing or decreasing by 60 minutes. And guys, on that note, that's where we're going to end today. I'm just going to stop the recording, but I will leave this up